we're looking at your reasoning and conditionals homework, and we're on 2D. If 3 points are coplanar, then they are collinear. So we need to prove it wrong with a picture. So let's draw 3 points that are coplanar but are not collinear. A counterexample makes the hypothesis true and the conclusion false. It makes the beginning of the sentence true and the end of the sentence false. The end, the conclusion, is where you prove it wrong. So I'll draw myself a nice plane that does not have edges, but we're representing it with edges. And then I'll put 3 points, and I'll make sure to not make them collinear. I just proved 2D wrong. That's called a counterexample. Okay, 3B. If 2 angles have a measure of 90, then the angles are congruent. We did not really go over truth value yesterday, but hopefully after looking at the answers, you kind of figured it out. Truth value means if it's true all the time, forever and ever, always true, you put true. If you can think of even one time when the statement is false, one little bitty counterexample, then the truth value is false. So right here in these, we're asking for true or false. It's false if it's false even one time in existence. If 2 angles have measure 90, then the angles are congruent. So I'll draw you a picture in case you're having trouble visualizing these. I've got one angle. I measured it with a protractor. It's 90 degrees. I have another angle. I measured it with a protractor, and it came out to 90 degrees. So if 2 angles measure 90, then the angles are congruent. Congruent means same size, same measure. On your sheet it says 2 segments with the same length, but these are 2 angles with the same measure. So that is true all the time, every time, no matter what. If you thought it was individual, it would have said if 2 angles sum to 90. You would have to see the word sum, guys. It doesn't say sum. They have. These 2 angles both have a measure, okay? So the converse. If 2 angles are congruent, then they measure 90. I'm abbreviating for time's sake. If 2 angles are congruent, then they measure 90. Well, I can think of lots of times that 2 angles are congruent, but they don't measure 90. 30 degrees, 30 degrees. I thought of a time, so it has a truth value of false. Inverse. If 2 angles do not measure 90, then they are not congruent. Let's think of 2 angles that don't measure 90. All right, 47 and 53. Those angles don't measure 90, and they're not congruent, so I found a time when the inverse is true. But when you're determining the validity, you try as hard as your brain power can to prove it wrong. So I want 2 angles that do not measure 90. All right, 110 and 110. They are not congruent. Uh-oh, they are congruent. I found a time when it doesn't work, so the truth value is false. Contrapositive. If 2 angles are not congruent, then they do not, measure 90. Okay, so they're not congruent. They have to be different angles. Well, if they're different angles, then I agree with the conclusion. They can't both measure 90 if they're different angles. So this one I agree with. This one is truth. I can't find a counterexample. And if you'll notice, there's a connection between the conditional and the contrapositive and the converse and the inverse. That is not a coincidence. That is a connection that actually will always happen. The original and the contrapositive will always have the same truth value, and the converse and the inverse will always have the same truth value. Okay, last one. I don't know how I feel about 4A, so I didn't write this and it's kind of weird to me. So let's figure out what I want to say about 4A. Which of the following statements has an inverse that is not always true? I think the answers just needed to be typed different. I think when it says which of the following, I think the answer should have been A and B. Do y'all agree? I think it should have been A and B. So I need to change that. If 3 points are not coplanar, I kind of have a problem with that because there's no such thing as 3 points not being coplanar. So honestly, what I would do if I could redo this worksheet, I would change this to 4, and then I would really like this problem a lot better. Let's pretend it was 4. If 4 points are not coplanar, then they are not collinear. And that is true all the time, every time. I think the person who designed it meant to put 4. So can we pretend it was 4? Then that would be true, and I like it. This one, the inverse is true. This is the one where the inverse is false because it has a counterexample. If those two lines are not parallel, then they do intersect. Realize when you get a not, they cancel out and it becomes a do. Well, okay, if lines are not parallel, what are their choices? Intersect, perpendicular, they're not parallel, oh, but they could be skew. So skew is our counterexample, and when you have a counterexample, then the truth value is false.